isn't it? We'll continue from there. As part of effort estimation, there are two models: top-down estimation and that is one model, top-down estimation, and another model is bottom-up estimation. Under top-down estimation, we started. So with the basic formula, effort E is equal to A into size to the power of B. That size is nothing but number of lines of source code. That is thousands of lines of code. That is KLOC, and A and B are the constants which depends upon the project related parameters. And as part of that top down approach, there is a very popular model called as COCOMO model that we started with in the previous class. It uses size but adjusts using some of the factors, and those factors we studied. Okay, these are some of the factors which will decide the values of factors A and B. And at the end, there is something called as adjusting factor. We'll calculate the adjusting factor, which is nothing but the product of all these factors. And these factors are called as the cost drivers, because these are the factors which will decide the cost. Hence, we call them as cost drivers. And I explained these things in the last class. Say, for example, if you want to achieve very high reliability, then the factor value is 1.4. So if you want nominal reliability, then it is 1.0. Similarly, in the case, say, for example, analyst capability. Say, for example, for the analyst, okay, so if he is very much capable to analyze the system, so and if you are having such an analyst, okay, then the cost factor is only 0.1. Okay, that means, say, for example, an experienced analyst. For your project, if you get an experienced analyst, you may have to, then while estimating the cost factor, so you should consider 0.71 for analyst capability. Say if you are considering someone who is a fresher, then you have to consider 1.46. Or some analyst with moderate experience, then you can consider 1.0. That's how you need to assign values for all these cost drivers or the factors that will decide the project cost. Then there is one more thing, that is adjusting factor. That adjusting factor is nothing but like this, some 15 parameters will be there. So these are the sample 10 parameters which are shown like this. A total of 15 factors will be there. So you need to, they'll take the product of all the 15 factors while calculating the cost. Then COCOMO effort distribution. How the effort will be distributed among various phases of software development. So that we are going to see now. Effort distribution among different phases is given as a percent of effort. That means, say for example, design phase, this much percentage of effort is required. Detailed design, this much effort is required in terms of percentage, like that. So that will be assigned as part of COCOMO model. Say for example, if I consider the overall cost of the project as 1 crore, okay, then product design, 16% we may have to spend. That means 16 lakh rupees. For detailed design, 24%, 24 lakh rupees we have to spend. So if you consider the overall budget is 1 crore. And coding and UT means unit testing. As we know that the person who writes the code is responsible of conducting the unit testing. So therefore, coding and unit testing will be done by the developers. So for that purpose, 38% of the amount you may have to spend. Okay, that means effort, overall effort. So based on the effort only, we assign the budget, isn't it? Then integration and testing, 22% of effort is required. See, when we calculate the overall effort of the project, it will be like in terms of hours and how many people are required, by assuming that each person works for 8 hours per day. So by using that as the basis, we calculate the effort. Okay, like that. So product design, we 16% of the effort, and detailed design, it occupies 24% of the overall effort, and coding and unit testing 38% of overall effort, and integration and testing 22%. So from this, it is very clear that so the more effort is required in development. So development constitutes writing the source code and doing the unit testing, that is coding and unit testing. That's about top-down approach. So what is the takeaway from the top-down approach? So effort calculation E is equal to A into size to the power of B, where A and B are the constants. Then, so those constants depends upon the various parameters. That is, there are 15 parameters. Okay, then by using that, they'll find out the adjustable factor. And size represents total the size of the source code in terms of KLOC. KLOC means thousands lines of code. Say for example, 25,000 lines of code, 30,000 lines of code approximately. So that is what the size means. Okay, example value for size is say 30,000. That is 30,000 lines of source code, like that. And A and B are calculated. So, and those values of A and B depends upon the nature of the project and the characteristics of the project. Nature, and that is dependent on nature and characteristics of the project. And ultimately, in COCOMO model, the effort distribution happens like this: for product design 16%, detail design 24, coding and unit testing 38, and testing integration and testing 22%. Next, we'll see bottom-up estimation. That is an alternate approach to top-down cost estimation, or cost estimation approach. And here the effort for components and phases will be first estimated. Effort for components and phases. See, here you need to understand what are components. Say there are 5 modules. Say for example, there are 5 modules in this project, in the proposed project. So 5 modules become 5 components. Then phases first estimated. Components and phases are first estimated. Then calculate the overall total effort required. Okay. So there will be various phases like requirements and requirements design, development, testing, and so on, isn't it? So first you need to estimate the effort required for the components and phases, then estimate the total effort. And here we can use activity based costing. That means all the activities are enumerated and then each activity estimated separately. So what are the activities involved? Say for example, requirements is one activity, preparing the design document is one activity, writing the source code is one activity, then testing is another activity. Okay, writing the source code also includes unit testing. Okay, after unit testing, the code will be delivered to the testing team. So remaining they will take care. Integration testing, system testing, and user acceptance testing, everything they will take care. Okay, during the course of testing, if they identify any bugs, that will be sent back to the developers to rectify it. Then once again, testing happens. So that loop continues until all the bugs are fixed. So here, first the activities are enumerated means you can line up all the activities one after the other in the sequence. Then calculate for activity 1 how much is the effort required. For activity 2 how much is the effort required. Like that. So first calculate the effort required for all the activities. Can group activities into classes, their effort estimate from past data. Say for example, you can group together requirements and design into one class. Okay, then coding and unit testing into another class. Like that, you can You can group activities into classes. Then what is the effort estimation procedure? Identify programs in the system and classify them as simple, medium, and complex. S means simple, M is medium, and C is complex. Define the average coding effort for SMC. That is simple program. What is the effort required to write a simple program? And what is the effort required to write medium complexity program? And what is the effort required to write a very complex program? Okay, so you whatever the programs that you may have to write, categorize them as simple, medium, and complex. Then you calculate the effort based upon the previous projects, based upon the experience gained from previous projects. That is very very important. So then here, then you may be thinking, who will assign these priorities? Like this program is simple, this is medium, and this is complex. It is the team lead or the technical lead. Okay, team lead or the technical lead will identify the programs as simple, medium, and complex. That you have to know. Then get the total coding effort. Okay, then so that then you can, once you identify them as simple, complex, and medium, then you can have a count how many are simple, how many are medium, and how many are complex. Then if you do the summation, you will get the total coding effort. Use the effort distribution in similar projects to estimate effort for other tasks and total. Use the effort distribution in similar projects. That means from the previous, from you look at the previous projects, and similarly you calculate the effort for other tasks. So now this is for development. Similarly, okay, for design, for example, okay, say for example, architecture is a simple design. Okay, activity diagram is a, say it is simple to come up with a architecture diagram. Okay, and you have to put medium effort to write the use case diagram, but you have to put utmost effort to come up with the ER diagram or the active sequence diagram and the activity diagram. So you classify them as complex, sequence and ER diagram as complex. Okay, so like that for all the different tasks, you assign the same concept of simple, medium, and complex. Then for other remaining tasks also, you calculate the effort. Okay, what are the other remaining tasks? Requirements, design, and testing. Okay, say for example, if you consider the example of testing, how to assign the priority as simple, medium, and complex. So what is the role of the tester? He is supposed to write the test cases and prepare the test data, then follow the standard procedures to test the application. Isn't it? That means they do functional testing. The task is to under first thing is they have the first thing that they have to do is they have to understand the requirements. They have to understand the requirements. So for that they will see the requirements document and they will understand so what is this system is all about. Then they'll prepare the test cases and test data. So if they in case if they are doing automation, they'll write the, see, automation means it is all about, say for example, you have a library management system, that is a project. So you want to do automation testing. So to do that automation testing, they'll create a testing framework. That means they'll totally develop one more project, which is an automation source code, which will test your library management system. That means now if I consider your library management system as project A, they will write one more project, that is project B. This project B, the task of this project B is to automatically test this project A. That means library management system. So what this project B will do, this will fetch the test data which is prepared by the test engineers, and that will be stored in the form of Excel files. So from Excel file automatically it will fetch, okay, and it will run the test for each of the functionality automatically, and at the end it will generate the test report. Okay, such a tasks will be taken care by testing team. testing and quality assurance team. So now there also you need to identify. See, in case of automation, see now automation is mandatory. Automation is mandatory. Say for example, uh, say um, for the given application, any given application, 18% of the functionalities can be tested using automation. This is just an average. Okay, if you consider a normal any project, okay, in between 80 to 90% of the overall functionalities can be tested using automation code. Remaining 10 or 15% of the functionalities, they have to be reviewed manually. They have to be reviewed manually because you cannot automate certain things. Okay, so there also automation people they'll be writing a lot of programs. So there also you can do the effort estimation. So they will be writing a lot of programs. Say for example, Selenium framework. If they select to do automation testing, they'll be using Java or Python, or even C Sharp can also be used. Selenium can be implemented using multiple languages. Selenium can be implemented using the popular choice for Selenium is Java and Python. And some people they use C Sharp also. So using any of these languages, they'll be writing the programs. There also they can identify programs into simple, medium, and complex. Okay. Now the concept here is see here the first identify programs in the system and classify them as simple, medium, and complex. So that is they are telling as part of development effort. See in testing also they will be writing a lot of programs to test the application. So there also similarly you can follow the same procedure. So for automation, when they write the source code to automate the testing process, there also you can identify small, medium, and complex. Similarly, in the design phase also. So depending upon the nature of the diagram, you can consider them as simple diagram, medium complexity diagram, and complex diagram. Say for example, level 2 DFT. So level 2 DFT will give you in detail information about like what is happening inside the project. Okay, that can be considered as complex. Context diagram is simple. Architecture diagram is simple. Use case modeling is okay, medium complexity, like that. So use the effort distribution in similar projects to estimate effort for other tasks and total. So whenever they estimate the effort, so they have to use the previous projects knowledge from the previous projects, okay, to estimate the effort for the current project. Refine the estimates based on project specific factors. So then once the effort is calculated, try to refine it based on project specific factors. So what are project specific factors? So as I told, so the 15 factors. Okay. So whether you need very high reliability or you need more security. So depending upon that, you need to adjust the factors. That's about bottom up approach. Student, anything you want to ask? Hello? Students, anything you want to ask? Okay, I'll continue. Scheduling and staffing. Let us see what is project scheduling. See, project scheduling is all about scheduling the resources to a project such that the project can be accomplished in stipulated time and within stipulated budget. So project scheduling is very, very important. Project scheduling is a tool is at two levels. So one is overall schedule and detailed schedule. So let us see what is overall and detailed schedule. Overall schedule comprises of major milestones and final date. Okay, so the core components of overall schedule is the milestones, major milestones, and final date. Okay, so examples for major milestones is, say for example, within 1 month You have to prepare system requirements document. That is one milestone. After that, within another 1 month or 1.5 month, you have to come up with sy- system design document. That is one milestone. Then after that, within another 8 months, you have to come up with a complete source code. You have to finish the complete source code. That should be ready. That is another milestone. Okay. After that, after another 4 months, you have to finish off testing. Your test report should be ready. Okay. So that is another milestone. Okay, like that. So the overall schedule comprises of major milestones and final date. Final date. That is the delivery software delivery date. Then detailed schedule is the assignment of lowest level tasks to resources. Okay, so detailed design deals with identifying the lowest level tasks, such as, say, for example, who has to prepare architecture diagram, who has to prepare DFD, okay, who has to write the source code, and who has to prepare the test data, who has to write the test cases. Okay, assigning the tasks and resources. Okay, that is what the detailed design will do. And at the same time, it will also assign the resources. Say, for example, say for this development, okay, these tools are required. Okay, those resources are to be allocated. So that is also part of detailed design. Because during each and every phase of the software project, they use some specific tools. Okay, those tools are nothing but resources. Okay, those are also considered as resources. Then overall schedule. The overall schedule depends heavily on the effort estimate. For an effort estimate, some flexibility exists depending on resources assigned. So whenever we say we are assigning the effort, okay, we are estimating the effort, there should be some flexibility. So the example for that is, say for example, a 56 person months, see 56 person months. The meaning is the project can be done in 8 months and 7 people. So 18 to 7 is how much? 56. Okay, that means 8 months, 7 people has to work, and each day they have to work 8 hours. That is called 56 person months. Okay, look at your students. If 8 months, 7 people are working consistently, 8 hours per day, we call it as 56 person months. Okay, and say for example, say initially we assume that the project has to be completed within 8 months, and the total effort required is 56 person months. Okay, let us assume like this. The effort required is 56 person months. So then we thought, okay, let us finish off this project within 8 months. So then we thought only 7 people are required. Only 7 people are required in case if you want to finish within 8 months. Then somewhere we felt, okay, it is better to finish 1 month early and keep 1 month as standby. Okay, let us deliver the software, try to deliver within 7 months. Then we have to increase our manpower by one number. That is 7 months with 8 people. Okay, that flexibility will be there. Okay, so whenever we do the estimation, always there will be buffer time. Okay, always there will be buffer time. Stretching a schedule is easy. Compressing is hard and expensive. Okay. See, stretching that means taking more time is easy, but compressing the time, okay, compressing the overall project duration, that is very hard, and it is very expensive as well. One method is to estimate schedule S as a function of effort in person months. PMs means in person months. 1 minute, I'll make it as Answer. Answer. One minute. Yes. One method is to estimate schedule S as a function of effort in person months. Okay. Can determine the function through analysis of past data. The function is nonlinear. Kokomo S is equal to S is what? Okay, students, I am back. Can you hear me, students? Hello? I want to reply. Can you hear me?
Yes, sir.
Hello? Yes. Okay, students. So using the Kokomo model, how to how to estimate the schedule. So the estimate schedule S is equal to 2.5 into E to the power of 3.8. So 2.5 is a constant value. E stands for effort. Effort already we have calculated. So okay, E is equal to A into size to the power of B, where A and B are constants depending upon project related factors. Okay, so that 2.5 into E to the power of 3.8. That gives you estimate schedule. Then often this schedule is checked and corrected for the specific project. Okay, even after calculating the schedule, okay, once again it has to be reviewed. Checked means it has to go through reviews to ensure that it is correct. Okay, for the specific project. One checking method is square root check. Okay, there is a technique to how to check this value for its correctness is the name of the technique is square root check. Determine, okay, this diagram will show you so how to like determining overall schedule from past data. See here, the x-axis is effort in percent days. Okay, x-axis is percent effort in terms of percent days, and y-axis is schedule means in terms of days, how many days required. Say for example, if okay, if you consider here 1400 people. Okay, so where is the convergence point? Okay, schedule is okay. Okay, students, first we need to understand what are these blue points. See, these blue points are nothing but the activity milestones. Okay, these are nothing but activity milestones, and this shows the progress. This black line shows the progress, and this x-axis represents the effort in percent days, and y-axis represents schedule in terms of days. Then how to determine milestones? Okay, with effort and overall schedule decided, average project resources are fixed. With effort and overall schedule decided, that means once you decide this is the effort required, and once you prepare the overall schedule, then average project resources are fixed. Okay, what is the meaning of fixing average project resources? Say for example, So for this project, so this is the, say for example, J2EE is the framework, okay, which you are going to use. So for front end design, we are going to use HTML along with JSP. So for core logic, we are going to use core Java, okay, and for database interaction, Hibernate, okay, and the database, say for example, SQL Server, okay, and what are the other technologies we may be using like XML, okay, then like that, okay, we have to fix, okay, we have to fix the resources. Then for project management, say for example, Jira is a resource for project management. Then for testing framework, Selenium, okay, and once again to implement Selenium, the language what you are selecting is, say for example, Java. Using Java, we have to implement Selenium framework to do automation testing, okay. Then fix, okay, so the team members, okay, these are the team members for automation testing. So these are the team members for manual testing, and this is the team for development, and he, okay, this person is a team lead, okay, like that. So how many teams are like that, how many teams are required, sub teams, okay. So that assignment has to be there, okay, that will be almost, okay, that will be almost fixed. Once the effort and overall schedule is decided, average project resources are fixed. So here resources means manpower is also resource, software is also a resource. Okay. Whatever is required for the project, everything is considered as a resource. Either it can be a software or a technical manpower. Manpower ramp up in a project decides the milestones. That means, so how much manpower you have. Okay, if you have more manpower, you can reach the milestones at the earliest. Otherwise, it will be delayed. Okay, that's the meaning. Manpower ramp up in a project follows a Rayleigh curve. Rayleigh curve. Okay, so if you have done mathematics, if you have used Rayleigh method, then you will come to know what is Rayleigh curve. It looks like a Rayleigh curve. Okay, in the next diagram, I will show you how the Rayleigh curve will look like. In reality, manpower buildup is a step function. Manpower buildup is a step function. That means, say how to see the meaning of step function is that, say for example, let us assume, so there is one fresher, okay, simply if you assign some work he cannot do. So what you are supposed to do, you ask him to work, okay, along with one senior developer, so that the senior developer will handhold him every day in each and every phase of his work. So if such thing happens for, say for example, for 2 to 3 months, okay, you can improve the skill set of the fresher engineer. That is called step function. Okay, such measures have to be taken to ramp up the manpower. See this diagram, see here, this curve looks like a Rayleigh curve. This is what the shape of the Rayleigh curve. Okay, see for design, say for example, okay, this is the effort required. Okay, so for development, you can see here. So see here, more effort is required. That means more manpower is required. Okay, and for testing, very little effort is required. And also look at the duration. Look at the duration for design. Build, see, build means build is nothing but design. See, build is nothing but coding. See, the meaning of build is that, say for example, you have written the program, you have done the unit testing, and you have ensured that it is working fine. So then your program is called as a build. The build is ready. The build is ready means you have written the code, tested. That means unit tested, it is working fine. So then build is ready. Then testing. So from this diagram, we understand that we need, okay, see here, say for example, here, say for example, we need 10 people for design. Okay, if we need 10 people for design, then for development, for example, we may need 20 people. Okay, and here for design 10 people, say for example 1 month. Okay, and here for development 20 people, 2 months, and for testing Okay, 5 people, 1 month. You can assume like this. Okay, this shows manpower ramp up. See here, here only the team size is, say for example 10. So you have ramped up to 20. So once the testing is, the development is done, so then you need only very few resources. That is only 5. Okay, this is manpower ramp up graph. This graph shows you how to ramp up manpower. Then milestones. With manpower ramp up and effort distribution, milestones can be decided. See how well you can ramp up the manpower. Okay, that much easily you can achieve the milestones. So if you delay in ramp, so in getting the manpower at right time, obviously achieving the milestones will be delayed. Effort distribution and schedule distribution in phases are different. See, effort distribution is different and distribution is totally different for different phases. Generally, the build has larger effort but not correspondingly large schedule. So the build has larger effort. That means to prepare the source code, you need lot of effort compared to any other phase. Okay, look at here. The COCOMO model specifies distribution of overall schedule. Okay, like this. For distribution, 19% of the effort, and for programming, 62% of the effort. For integration and testing, 18% of the effort, as per bottom-up approach. Okay, as per bottom-up approach, the COCOMO model says for design 19%, programming 62%, and integration 18% of the overall effort is required. Okay, now look at the example schedule. Okay, so you may get a question like explain project scheduling with example. So this is the example. See here, the first column you have the task, then duration in terms of days, then work. Okay, how many days? Here also work also in terms of person days. P days means person days. Start date and the end date. Okay, here for project initial tasks 33 days, person work 24 days. Okay, starting date 4th May. 5 slash 4 means 5 is the month number. Okay, May 4th is the starting date. June 23rd is the ending date. Similarly, for training, so 95 days duration is been given as per the schedule, but person hours required are 49. Starting date is 8th of May, and training end date is 29th of October, September. Then knowledge sharing 78 days duration. Okay, this is the percentage and this is the starting date and ending date. Similarly, elaboration iteration 1, then construction iteration 1. Okay. Okay, this is the sample schedule. So here you may be thinking, okay, project initial tasks. So what are the project initial tasks? So talking to the, so the project initial task is like effort estimation, then collecting the requirements, preparing the SRS document. Okay, those are all the client meetings. Okay, all those things are part of project initial tasks. Then training. Training means training the manpower. So, say for example, say one of the team. So earlier they used to work on .NET based technologies. Now you are expecting them to work on Java based technologies. So obviously you have to give them training. Okay, that is one aspect. Another aspect, say for example, they are well versed with the programming, but they don't have the domain knowledge. So you have to provide the training. So therefore, training is very much essential. Then knowledge sharing. So knowledge sharing is very important. So we cannot expect that all the team members are very well versed with whatever the tools and technologies that they are using. They should know why they are using and why they have selected those specific tools. And at the same time, knowledge sharing is very much essential, especially when you are changing the resources. Say, for example, there are 5 members in your team. So, due to some reason, one of your teammate is leaving the job. So before 1 month, you have to hire one more person. Okay, you have to uh, hire one more person to your team, so that so before the leaving, so that developer will tell so what were the tasks that you are doing as part of that project. Okay, and he will make him understand what is the work process there, everything. So that is called knowledge sharing. So in industry, they call it as KT sessions. KT means knowledge transfer sessions. In industry, they call it as KT sessions, that is knowledge transfer sessions. So then elaboration iteration one. So elaboration iteration one. Okay. So this is very important. Elaboration means, see, once you decide, okay, these are the resources required and these are the manpower required for my team. And see, there the manpower includes the people involved in requirements phase, design phase, testing, quality assurance, development, everything, and even the operations team. Okay, so you have to tell them, elaborate them. So, what is the project? So, who is your client? Okay, with what kind of requirements they have come to your company? Okay, so what are the requirements? So, and what is the process involved to develop that project? Okay, everything has to be elaborated. That is called elaboration iteration one. Then construction iteration one. Okay, actually this is the next phase. Okay, so here you'll decide. Okay, so like specifically you'll assign the tasks to resources. So in this phase you'll be assigning the task, you'll be mapping tasks and resources. So for this task, who are the resources? So for example, if design is the task, who are all the resources? If okay, if the task is writing the source code, so who are all the resources? Okay, that is construction iteration one. Then detailed scheduling. To reach a milestone, many tasks have to be performed, isn't it? See, if you want to reach one milestone, many tasks have to be performed. Say for example, so the very first milestone is, if I consider, the very first milestone is preparing the requirements document. So before that, many tasks have to be performed. So what are those tasks? So you have to do so many meetings, formal and informal meetings with the client. Okay, and so who will be doing that? Business analyst will be doing that. So he has to talk to the project manager, and he will be designating one person to prepare the system requirements by consulting that system analyst. Then he'll be having okay, 2 3 other people to prepare the user requirements. So because system requirements are abstract in nature, then that they have to be converted into user requirements, isn't it? So okay, like that. So before preparing one document, so many other tasks have to be performed. That is called detailed scheduling. Lowest level tasks, those that can be done by a person in less than 2 3 days. Okay, the meaning of lowest level tasks is, say, one meaningful task, okay, very small task that can be done by one person in a span of 2 3 days. Okay, that is an example for one lowest level task. Then scheduling. Decide the tasks, assign them while preserving high level schedule. Scheduling means deciding the tasks. Okay, say for example, in case of requirements document preparation. Okay, so getting the user stories from the user, that is one thing. Okay, so then say for example, in case, say for example, if your team wants to follow SDLC, that is waterfall model, then you have to prepare detailed requirements document, isn't it? Then, so as per the procedure, first you start with system requirements, then user requirements, and so on. You can then build it as per the ACM IEEE standard template. You can prepare. Decide the tasks, assign them while preserving high-level schedule. Okay, first once you decide the task, then that has to be assigned to the suitable individuals. It is an iterative task. If cannot fit all tasks, must revisit high-level schedule. It is an iterative task. Say for example, you cannot expect that one person will do only one task. Okay, you assign one task to one person. Okay, if he finishes that, you assign one more task. Okay, so and sometimes it is also evident that sometimes some people will fail to do some particular task, so that can be assigned to some other individuals. So that is all part of detailed scheduling. So students will stop it here. We'll continue. We'll continue in the next class. So from detailed scheduling, we'll continue from the next class. Answer for your attendance. You send one.
Yes, sir.